Hello students, in this video we will be seeing a very important deleted topic, that is radioactivity. In the last I have done some previous year questions, so watch this video till the last. You will get the concepts as well as the models how to do the sums. If you have not yet subscribed to Easy Exam Academy channel, please do subscribe and click that follow button for more updates. Let's get started. Radioactivity was discovered by Henry Becquerel in 1896. He discovered it purely by an accident. It is like this. They took a material and they covered it with some kind of paper, and there was a photo paper in the back end. Even though the material was covered with the paper, there was some deposits on the photo paper, which he concluded that there is something being emitted from the material and it is piercing the paper and going and hitting the photographic plate. So radioactivity is a nuclear phenomenon involving the decay of unstable nuclei. There are three types of radioactive decay. Number one is alpha decay, wherein a helium nucleus is emitted. And the second one is beta decay. Beta decay is divided into two types. One is beta plus decay and another is beta minus decay. Beta minus decay involves electron emission and beta plus decay involves positron emission. The third thing is gamma decay. So gamma decay does not involve any particle coming out, but rather than it is a gamma ray, which is an electromagnetic wave that is emitted. In radioactivity, we need to understand the law of radioactive decay. So the law of radioactive decay states that the decay ray is directly proportional to the initial number of nuclei that is present there. Let us say, example, we have two rats. Then the two rats will mate and produce around 100 rats over the end of the month, let us say. So 2 rats is producing 100 rats. That does not mean that 4 rats will be producing 200 rats. The 4 rats will be producing some around 400 rats. So this is called the exponential population growth. In a similar way, this radioactive decay follows an exponential decay. Now we will derive the solution. dN by dt is equal to minus lambda into n. Minus means that it is undergoing decay and n is the initial number of nuclei. We are going to simply interchange it. Dn by n is equal to minus lambda into dt. Integrating on both sides, log n is equal to minus lambda into t, where n goes from n0 to n and t goes from 0 to t. n0 is the initial number of nuclei. N is the amount of nuclei that is left after the decay. So log of n minus log of n0 is equal to minus lambda into t minus 0. So log of n by n0 is equal to minus lambda into t. So changing it, n equal to n0 into e power minus lambda t. This is the general formula that we will be using. N is equal to n0 into e power minus lambda t. Now activity and decay rate. So there are some notions that you need to understand. Activity is denoted by R. The units of activity, SI units of activity is Becquerel. There is another unit also that is called as Curie, named after Marie Curie. 3.7 into 10 power 10 Becquerel is equal to 1 Curie. Activity means the dN by dt, that is equal to minus lambda into n. The rate is equal to lambda into n. In your question, if they ask activity, then that means they are mentioning dN by dt or lambda into n. Very, very important thing to understand is the half-life and mean life. Half-life means what is the amount of time that it takes to decay to the half the initial number of value. Initially, let us say 100 nuclei are there. And what is the time it takes to go to 50? That is called as half-life. So half-life, how to derive the expression for half-life? N is equal to n0 into e power minus lambda t. N can be replaced by n0 by 2. That is equal to n0 into e power minus lambda t. Cancel it out. And 1 by 2 is equal to e power minus lambda t. Applying log on both sides. So log 2 is equal to lambda into t. So t half is equal to log 2 divided by lambda, where log is a natural logarithm, or ln, ln2 by lambda. So ln2 value is 0.693. So that if you substitute, so t half is equal to 0.693 divided by lambda. This is the general formula. The mean life means 1 by lambda. Mean life is defined to be inverse of the lambda. Now let us talk about alpha decay. Alpha decay means a helium nucleus will be released. So helium nucleus contains 2 protons and 2 neutrons. So the atomic number of helium is 2 and the mass number of helium is 4. Helium-2, 4. Helium-2, 4 nuclei only is emitted, not the elemental helium. Just the nuclei of helium is called as alpha particle. So when uranium-238 undergoes decay to thorium-234, alpha particle is emitted. That means helium is emitted. When alpha particle is emitted, the atomic number reduces by 2 and the mass number will reduce by 4. So the Q value of the reaction that denotes the energy. So we know that in nuclear reactions, the final mass will be little bit less than the initial mass. So the initial mass of the uranium will be higher than the final product mass. This is the underlying principle of radioactivity. When a nucleus is more stable, that means it has less energy, and when the nucleus is less stable, it has more energy. So uranium is less stable, it has more energy, it decays by releasing energy into thorium and an alpha particle. Then beta decay. Beta decay, as I have said before, beta decay involves beta minus decay. Beta minus decay involves a neutron disintegrating to proton and electron plus an anti-neutrino particle. Whereas beta plus decay involves decay of proton to neutron and a positron emitting a neutrino. So neutrinos are neutral and low mass and weakly interacting particles. Neutrinos are everywhere around us. Neutrinos are everywhere around us. At a given point of time, each and every moment, each and every second, millions of neutrinos are passing through us. It can penetrate almost anything, and it is very, very difficult to detect the neutrinos. So in beta decay, the characteristic of the reaction is there is no change in the mass number. If there is no change in the mass number, if beta minus decay undergoes, the atomic number will increase by 1. If beta plus decay undergoes, the atomic number will decrease by 1. Last, we have the gamma decay. Gamma decay is nothing but the emission of gamma radiation. We know that in atoms, electrons have many states. When electrons from higher energy states comes to a lower energy state, it releases energy in the form of light, that is h nu, hc by lambda, that we have studied in the atoms lesson. Similarly, the nucleons inside the nucleus will have some different energy states. When an excited nucleon comes down to the ground state or the lower energy state, it releases energy, but that energy is in mega electron volts, unlike the atoms which are in electron volts. So mega electron volts corresponds to the release of higher energy spectrum, which are gamma rays. So X-rays, gamma rays, these are in the higher energy spectra of the electromagnetic spectrum. In atomic decay, we have the visible light or infrared light, but in nuclear decay, in nuclear emission, we have the gamma or X-rays. So gamma means a radiation is followed. So the characteristic of gamma decay is there is no change in atomic number or no change in mass number. It is simply a nucleus, higher energy state nucleus going to the lower energy state nucleus. Let us discuss some previous year questions. The half-life of a radioactive nuclei is 100 hours. The fraction of original activity that will remain after 150 hours would be. There is one important formula that you need to remember. N is equal to N0 into 1 by 2 into T by T half, where T is the amount of time and T half is the half-life of the substance. N is equal to N0 into 1 by 2 into T by 1 by 2 power T by T half. Here in the question, they have given the nucleus. Here in the question, they have given the half-life of the nucleus is 100 hours. So T half is equal to 100 hours. Then we have time that is given as 150 hours. So directly substituting in the formula, we get N is equal to N0 into 1 by 2 whole power 150 divided by 100. So that comes to be 3 by 2. So N is equal to N0 into this becomes 2 power 3 by 2. That means 1 by root 8, which is N0 by 2 root 2. So this N means the amount of nuclei left. So how much nuclei has disintegrated? The disintegrated nuclei will be N0 minus N. So this is just for your information. Moving on to the next question. Two radioactive nuclei P and Q in a given sample decay into a stable nucleus R. So P decays to R. Q also decays to R. At time t equal to 0, the number of P species are 4 N naught and that of Q are N naught. Half-life of the P for conversion to R is 1 minute. So that means the T half for this reaction 1 minute, whereas T half for this reaction is 2 minutes. Initially, there are no nuclei of R present in the sample, 0 and 0. When the number of nuclei of P and Q are equal, the number of nuclei of R present in the sample would be. So he is asking us to find the number of the R that is present in the sample. So first of all, we need to identify at what time P and Q will be equal. We need to identify that first. So let us write down NP is equal to initial number of nuclei is 4 N naught into 1 by 2 T by T half. T half is 1 minute. Then NQ will be equal to N naught into 1 by 2 into T by 2 minute. Let us equate them. So 4 N naught is equal to 4 N naught into 1 by 2 whole power T is equal to N naught into 1 by 2 whole power T by 2. If we solve this, we'll get T is equal to 4 minutes. That means at T is equal to 4 minutes, we have the number of P and the number of Q are equal. How many half-life are there for P? Let us calculate like that. So how after T equal to 4, how much of nuclei of P is left? Let us calculate that. So initially 4 N naught is there. That means T is equal to 4 minutes correspond to 4 half-lives, right? So after one half-life, it goes to 2 N naught. Then after another half-life, it becomes N naught. And then after another half-life, it becomes N naught by 2. So one half-life after 1 minute, then another minute, then another minute, then again, finally, there is another half-life that is, it becomes N naught by 4. So the amount of sample of P that is left is N naught by 4. So NP is equal to N naught by 4. You can use that same formula also to deduce the N naught by 4 value. T is equal to 4 for Q means that is 2 half-lives. So initially N naught is present. After 2 minutes, you are going to get N naught by 2. Then after another 2 minutes, you are going to get N naught by. So both are equal N naught by 4. So NP is equal to, so NQ is also obviously equal to N naught by 4. Now we have NP is equal to NQ is equal to N naught by 4. So P is disintegrating to R. N naught by 4 is left. That means how much it has disintegrated, that is R. So N naught by 4 is left here. Initially 4 N naught is there. N naught by 4 is remaining. So that means 4 N naught minus N naught by 4 will be disintegrated. That is the R value, which is equal to 15 N naught by. Similarly, Q disintegrates to R. NR in this reaction will be N naught minus N naught by 4. So N naught by 4 is left out. Initially N naught was there. How much it has disintegrated? N naught minus N naught by 4. That becomes equal to 3 N naught by. So how much total R value is there? How much total R is there? So that is 15 N naught by NR total is equal to 15 N naught by 4 plus 3 N naught by 4, which becomes 18 N naught by 4. That is 9 by 2 N naught. So the final answer is 9 by 2 N naught. Very interesting question. This explains many things about the radioactivity. So this is a very interesting question. A piece of wood from the ruins of an ancient building was found to have a C14 activity of 12 disintegration per minute per gram. That means the rate is given of its carbon content. The C14 activity of the living wood is 16 disintegration per minute per gram. How long ago did the tree from which the wooden sample came die? Given the half-life of C14 is 5760 years. So this process is called as carbon dating, with which we are able to find the exact dates of all the dinosaurs and all the fossil fuels that existed millions of years ago. So how do they do it is by measuring the rate of the decay of the present sample and knowing the half-life of carbon C14 that is already known. C14 carbon is a radioisotope of normal carbon, that is C12. So we can write that the living wood R naught is equal to 16 disintegrations per second. R is equal to 12 disintegrations per second. Similar to the formula n is equal to n naught into e power minus lambda t, we have the formula R is equal to R naught into e power minus lambda t. Just dividing with respect to the time, we get this formula. R is equal to R naught into e power minus lambda into t. If you apply log on both sides, we can directly write t is equal to 1 by lambda into ln of R naught by R. If we apply log on both sides and interchange it, we can directly write t is equal to 1 by lambda into ln R naught by. We know the half-life, we know the relation between the half-life and the lambda value, where t half is equal to ln 2 divided by lambda, that is 0.693 divided by lambda. Lambda can be written as 0.693 divided by 5760. R naught we know, R we know, we can simply plug in the values and find out the final answer. So this is all very calculative. The final answer comes out to be t is equal to approximately 2392 years. So dear students, hope you have understood about radioactivity. This is a very important deleted topic that is present in all your entrance examinations. If you have any doubts or questions, please feel free to put in the comment section. Bye.